Mars experienced exactly what happened to Earth in terms of differentiation or differentiation. What is meant by differentiation here is the process that results in a difference in the density and components of each layer of the planet, such that the core of the planet is of high density and what is above it is less dense than it. The current model of Mars is as follows. The core extends over a radius of 1,794 plus or minus 65 kilometers, 1,115 plus or minus 40 miles, and is mainly composed of 16 to 17% iron, nickel, and sulfur. This composed heart, iron sulfate, is partially liquid, and its concentration is twice that of the other lighter substances in the core. This core is surrounded by a mantle of silicate, which forms many of the planet's tectonic and volcanic features but now appears dormant. Besides silicon and oxygen, the most common elements in the Martian crust are iron, aluminium, magnesium, calcium and potassium. The average thickness of the crust of Mars is 50 kilometers, 31 miles, and its maximum height is 125 kilometers, 78 miles, while the thickness of the Earth's crust is 40 kilometers, 25 miles. This thickness in relation to the size of the Earth is equivalent to 1/3 of the thickness of the crust of Mars in relation to its size. In 2016, the InSight spacecraft analyzed the planet using a seismometer to better model the planet's internal composition, and on November 26, 2018, after a journey of 485 million kilometers, 301 million miles, the rover successfully landed on the surface of Mars in the Elysium Planitia region at 7:53 p.m. Greenwich Mean Time. The seismometer will be deployed and drilled for the temperature probe. It will also carry out a series of radio science experiments to complement studies of the internal structure and rotation of Mars. Mars terrain, by virtue of it being a terrestrial planet, consists of minerals containing silicon, oxygen, and other elements that typically form rocks. The surface of Mars consists mainly of basalt and tholei, although the planet is richer in silica than basalt and may be similar to Earth's andesite rocks or silica glass. Parts of the southern highlands include detectable amounts of high-calcium pyroxenes. High concentrations of the minerals hematite and olivine were found. Much of the surface is covered with iron, oxide dust, carbon and frozen water. It should be noted that the highest mountain peak in the solar system is Mount Olympus, which reaches a height of 25 kilometers. As for the canyons, the red planet is distinguished by the presence of the largest canyon in the solar system, and the Mariner Valley Canyon extends to a distance of 4,000 kilometers, and to a depth of up to 7 kilometers. Mars has a gravitational field but no magnetic field. Parts of the planet's crust appear magnetized, indicating alternating polarity reversals of a dipole field occurred in the past. This magnetism of magnetically sensitive minerals is similar to the currents found on Earth's ocean floors. One theory, published in 1999 and re-examined in October 2005, it indicates plate tectonic activity on Mars 4 billion years ago, before the planetary dynamo stopped working and the planet's magnetism faded. It is believed that during the formation of the solar system, Mars was created as a result of a random process of accretion of material accreted from the protoplanetary disk orbiting the Sun. Mars has several distinct chemical features resulting from its location in the solar system. Elements with relatively low boiling points, such as chlorine, phosphorus, and sulfur, are more common on Mars than on Earth. These elements may have been pushed outward by the solar wind. After the formation of the planets, everyone was subjected to what is called delayed heavy bombardment. About 60% of the surface of Mars shows a record of impacts from that period, while much of the remaining surface is probably surrounded by massive impact basins resulting from those events. There is evidence of a massive impact basin in the northern hemisphere of Mars, extending over an area of 10,600 by 8,500 kilometers, 6,600 by 5,300 miles, or nearly 4 times the size of the Moon's South Pole Basin, Aitken Basin, and is considered the largest shock basin ever discovered. Now, this theory suggests that Mars was struck by a Pluto-sized planet or asteroid about 4 billion years ago. It is believed to have caused Mars to split in half, creating the smooth Arctic Basin, also known as the Borealis Basin, which covers 40% of the planet. The geological history of Mars can be divided into several periods, but the following are the three primary periods. Notion period. The oldest existing surface of Mars formed 4.5 to 3.5 billion years ago. Notion age surfaces are broken by numerous large craters. The Tharsis Bulge, a volcanic rise, is thought to have formed during this period, with extensive inundation of liquid water late in the period. Hesperian period, named after Hesperia planum 3.5 to between 3.3 and 2.9 billion years ago. The Hesperian period is characterized by the formation of extensive lava plains.